Over the last year, thousands of public swimming pools and spas were modified in an attempt to bring them into compliance with the Pool and Spa Safety Act. The Pool and Spa Safety Act and the ASME suction fitting standard address more than the cover. The entire system must be considered.
Nearly all reported entrapment cases involve single suction outlet systems where the outlet itself was easily accessible, such as wading pools or hot tubs. The cover itself may have been missing, broken, or otherwise damaged. Additionally, the facility may have been poorly maintained or the circulation system wasn't correct to begin with. All these lead to conditions that can create an entrapment. The goal of the Pool and Spa Safety Act is to address all entrapments and to ensure that the devices that are installed per the manufacturer's instructions and are operating per the manufacturer's instructions and the provisions of the Act.
In this series of training modules, we'll focus on assessing the system, selecting proper suction fittings, backing up single outlets, and finally, vacuum fittings, sidewall ports, and equalizers. We'll be using a flowchart from an American National Consensus Standard on suction entrapment avoidance. This standard is not part of the Pool and Spa Safety Act, but it does cover the steps necessary in addressing suction safety. You may use this or create your own inspection form, but be certain to cover all the issues. Inspection is a complex process when done correctly. Let's assess the system. Of course, if your state allows pools to be built with no suction outlet, you may simply disable the current drain as allowed in the Pool and Spa Safety Act. By eliminating the drain, you have completely eliminated the hazard and all issues associated with human error. Most of the reported suction entrapments and deaths have been caused by human error or oversight. Check with local or state representatives to see if drain disablement is an option in your area. If the pool has a submerged suction outlet, vacuum fitting, or skimmer equalizer, then you must take the necessary steps to verify flow rate and the overall system configuration, including piping, suction outlets, and pumps. Here we start with how many pumps an outlet serves, and ultimately will determine the total combined maximum flow rate in gallons per minute, or GPM. Everything is based on this combined maximum flow rate, so it's imperative that you verify it, preferably with a calibrated flow meter or measured TDH and pump curve. If you haven't watched our training module on flow rate and TDH, please do so. We are going to use TDH in a very different way than it is traditionally used for most state public pool codes. Please note that TDH estimates using hydraulic calculations are not accurate enough to ensure flow rate. To use TDH, you must measure. Our overall goal in this section is to know the maximum system flow rate in order to size the suction outlet fitting. If there are multiple pumps connected to the suction outlet, assume they are all on and operated at the maximum flow for this system. It is impractical to use zero TDH on the pump curve, so some field verification may be required. Flow meters, or permanently mounted gauges, are susceptible to corrosion, incorrect installation, and loss of calibration. Don't allow a digital meter to give a false sense of confidence in the number. Digital flow meters can be installed incorrectly and lose calibration as easily as flow rotometers. In general, make sure there are at least 10 diameters of pipe upstream from the flow meter, unless the flow meter is calibrated for use with less. In summary, our first step is to confirm how many pumps exist per outlet, the maximum flow rate of these pumps as installed, and then we'll assess whether the flow rate through these suction outlet covers is correct.